Hello, my name is Sam Kolodrubetz, and today I'm going to walk you through my Capstone project, which is machine learning analysis on fear and other emotions being used within news media. Here's a brief overview of what I'll be going over today, including an introduction to my Capstone topic, the questions I'm trying to answer in the analysis, the methods and data sets used during the project, and several slides of my initial exploratory data analysis. I'll finish off by going over quickly the machine learning model I'll be using and some outcomes that I expect to achieve while doing my analysis. Now let's get into it. If you've consumed any form of news media in the United States, you're probably familiar with the term, "if it bleeds, it leads," which basically tells us that if a story is controversial or provokes feelings of fear or despair, it is much more likely to be published and be a popular story. This semester, I'm trying to quantify that level of fear being used by various news outlets in their news articles. While the prevalence of fear-based journalism is hard to deny, why is it important to do this analysis? To put it simply, understanding the motives behind various news outlets and how stories are written can help people increase their media literacy, or their ability to critically evaluate the sources of news. In particular, understanding how fear is used as a tool to increase the viewership for these outlets can aid people in recognizing sensationalized reporting and avoid falling for these tactics. With that being said, I have two main questions that I'm attempting to answer in this project. First, is it possible to quantify the level of fear and other emotions such as anger and sadness in current news articles from several news outlets? Second, is there a difference in these level of fear being used across various platforms as well as across several years? To answer these questions, I'm going to be taking a two-step approach to quantify the levels of fear being used. To start, I will build a recurrent neural network, or RNN, to classify tweets based on their given and labeled emotion. Next, once the model is built and performing at a decent accuracy, I'll use it to classify real-world news articles that are being scraped from the web to determine the amount of fear and other emotions that are being used. Now let's take a look at the dataset I will be using in step 1 of my analysis. The emotion text dataset is a publicly available dataset with over 416,000 labeled tweets, each consisting of 2 columns. First is the actual text of the tweet that has been pre-processed, and which I will use in the sentiment analysis. And the second is the label or class of the given tweet. Each tweet falls within one of 6 emotions: fear, anger, sadness, joy, love, and surprise. While fear is the main emotion of focus during this project, having these 5 other emotions, which are both positive and negative, will definitely help create a more robust and accurate model. Next, to quantify the amount of fear being used by these various news outlets, I first need to obtain the articles in question. First, to capture a potential difference that political leanings may make in the fear levels used, I've chosen to use the Python library Selenium because each site has JavaScript embedded HTML on 3 different popular outlets across the political spectrum: a more neutral AP News, left-leaning CNN, and the right-leaning Fox News. Secondly, because different news topics may elicit different reporting styles, I've chosen to only focus my web scrape on one topic: politics. And lastly, to fully capture an overall level of fear, the more articles tested, the better. So I will attempt to have at least 100 articles from each site, with more being possible. Now we can look at some initial results from the emotion text dataset. Most of my exploratory analysis on the dataset was an attempt to learn more about the individual classes and how the RNN may be affected by this data's composition. Before that, however, I'm going to show you an example of the necessary text pre-processing that will be used both for the emotion text dataset, and the real-world news articles. First, for PyTorch to work with the data, a document, which in this case for the dataset is a tweet, but it can also be a paragraph or an entire article, that document needs to be transformed into individual vectors. This is called tokenization, which, as you can see, puts each word into its own vector. Next, we have to get rid of stop words, which are basically words that would add little to no value for the recurrent neural network that's going to be used. In this example, words such as I and the are removed. Finally, the last step is to transform the words into their root words by using the process of lemmatization. Lemmatization is incredibly important because without it, words with different endings will all be considered as different words, and the RNN will not be able to find these patterns within each emotion. For example, without lemmatization that you see here, the words days with an S and day will be considered different words and will each carry their own unique weight rather than being reused. Now we can get into a few plots. The first plot here is a simple frequency count of each class within the dataset. As we can see, sadness and joy have many more examples than the other emotions. A model with this class imbalance would end up favoring joy as the answer, so this must be fixed before actually creating the model. To do so, I'm going to downsample both sadness and joy to better match the other classes and the number of entries in those classes, which is going to be about 35 to 40,000 entries for each class. Next, we can take a look at the top 10 most frequently used words in the entire dataset. As you can see, most of these words are not really descriptive and do not match any emotion very well. In fact, this is the case for every individual emotion. For that reason, I elected to look at the top 11 to 21 rather than the 1 through 10 here, because showing the 1 through 10 would be rather redundant, and hopefully the next set of 10 words will be able to have more emotion matching words. Additionally, these top 10 words are good potential candidates for adding to the set of stop words to be removed, because some words such as like or get don't really add much emotional context. Now, looking at the top 11 to 20 words for both fear and surprise, these two emotions are great examples of seeing more contextually correct words. For example, afraid is a word that should be expected in a fearful sentence, while shock and overwhelm are definitely words to be used with surprise emotions or tweets. However, this does not hold up for the dataset subset of love and joy, however. For this reason, I decided to expand my search to get a larger look into the top 100, excluding the top 10. So we're looking at 11 to 100, top 11 through 111 words for each emotion using a word cloud. Word cloud for fear definitely gives us a much better picture of the class and unique lexicon used, and which will be utilized in any creation of the RNN. While common words that can be found with any emotion, such as even, see, and want, are still present, there's a much better distinction than only looking at 10 words. That same thing can be said for the lexicon of surprise, which has many words here that you can see that provokes a surprised feeling, such as impressed, shock, overwhelm. And lastly, while joy does not have many quote-unquote joyous words, the dictionary that you can see here is still unique and elicits more joyful emotions. The last part of my EDA revolves around the emotion polarity of a given class. While I'm creating a 6-class classification problem with my RNN, polarity only attempts to assign either a negative or positive value ranging from -1 being a very negative sentiment to 1 being a very positive sentiment, with 0 being little emotion shown within the given document. In plotting the histograms of each emotion's polarity, I'd expect the negative emotions to be closer to -1 and the positive emotions closer to 1. And as you can see here, the results were as expected. All the negative emotions in red on the top, including fear, anger, and sadness, are all skewed towards -1 negative polarity. And vice versa with the positive emotions of joy, love, and surprise, which are all skewed towards the right, being more positive polarity. The only thing that I didn't really expect was the fact that each histogram is centered around 0. With this being a relatively curated data set, I was expecting the polarity to be much more prevalent, but the results still hold. Lastly, as I mentioned before, the best way to tackle text data and natural language processing and sentiment analysis is using a recurrent neural network, because that allows the model to learn dependencies through time through a series, which in this case would be the vector of words being used to train the data. And this is really essential when considering the context of words and phrases and being able to look back into time to a previous phrase, sentence, or paragraph to better understand the context of the words being used and hopefully the emotions being elicited. And lastly, here's just a simple architecture of what an RNN that I'll be creating will look like. The RNN starts by assigning weights to the first vector, in this case, the word, and then moves forward through the vectors of words in order, taking into account all past information that it has learned, such as the phrases and words that has come previously, until the end of the document is reached. At that time, all the information is compiled and a prediction is given back to the user in the form of probabilities that the document belongs to each class. This is called the softmax activation function, which I'll be using, where all the probabilities of each 6 class will total up to 1, and that highest probability will be the output answer. Now, lastly, just a few outcomes that I kind of expect. So there's a paper that did a very similar thing on trying to classify tweets given 7 different emotions. And with so many classes working in this text data, high accuracy in the 90s is pretty hard to achieve. So in this paper, they only achieved around 60% accuracy with 7 classes. So I expect in the first step, the accuracy to be at least higher and hopefully up in the 70% accuracy range, since there is 1 less class than this paper. Similarly, with this real world news, I'm not expecting a completely accurate classification, just because of the different styles of journalism that could be going into each of these places. But at the same time, I am finding selected, curated articles that are meant to be fearful. And when testing my RNN on these curated articles, I would expect at least these ones to perform at a relatively high accuracy. And lastly, I expect the more partisan news outlets like CNN and Fox News to use more fear when compared to AP News, because AP News prides itself on being quote unquote unbiased. So definitely expect the more partisan journalism to have more fear and other emotions in it. And here are the references. Thank you for your time. Bye.